Mhm.
So in the memory analysis, last time we kind of saw that we have the memory, RAM memory image. And the first thing was actually to kind of know, suppose you get an image out of any system, you also need to know what was the operating system that was it was running, as well as kind of what was the service pack, maybe Windows 7 and service pack 1 or service pack 2, or maybe if it is 64-bit or 32-bit. Okay. And for RAM forensics, the gold standard framework is actually volatility, which actually does all the memory forensics for you. It will like kind of it will get all the artifacts for you, which will be kind of helpful to see if the system was compromised and if the malware is still residing on the RAM memory. Okay. So the first thing, whenever you kind of get a memory, maybe suppose you don't know what was the version when it was like, what was the system version of the OS that was running in that. What you can do is you can just kind of run the volatility, give the -f mean you give the file name of that image, of that RAM image, and then you give a plugin, write a plugin name is image info. So what it will do is like it will try to kind of check if it can predict what might be the version of that operating system from which this RAM memory was taken. So it's not like almost every time 100% correct, but 80% of the time it works, and kind of it will tell you the exact kind of operating system which was running on the system when this memory image was taken. Okay. So we have
So
actually,
how to verify that information, Pragyan? So you're
yeah,
saying 80% of the times it will be correct.
yeah.
So how
So
to check
uh,
whether we are in 80% or the 20%?
yeah. So what happened is like, most of the time, what will happen whenever you are taking a RAM image, you will be knowing. Like suppose there's an incident that a client system or any employee system got compromised. So when you are like talking with the employee, you will the in the employee in the company, maybe the seat and all, it will be mentioned at what device were assigned to this guy, and what is the current operating system running on that thing. Okay. So from there you can know that okay, this is the operating system that is running on the device. And also you can like ask the employee, and then you can just fill it. Okay. Then you can just tell it like hyphen profile. When you are like kind of analyzing the RAM image, you can just tell hyphen profile Windows 7 SP1. Okay. Based on like when you are, so most of the time you will be getting that information. But what I'm telling is there are some rare cases where you won't be knowing. Let's suppose abruptly you got a RAM image and you want to kind of perform the forensics of that using volatility. So in those rare cases, maybe you are not knowing the window system image that is running on that. Okay. So on those rare cases, you might run image info plugin, and it will give 80% of the time that okay, this might be the, like it might tell that the profile was Windows 7 SP1 or Windows XP1. And 20% time if you don't get, either you try like maybe Windows 7 or Windows 10. Okay. But what will happen, like suppose when you gave a wrong profile, maybe what will happen, you will get the output, but it will be kind of non-readable. Okay. It won't parse the data properly. Okay. So but you can like, volatility has kind of mentioned what all profiles they support currently. So even they supports Windows 10 now. So when I started with this, Windows 10 was not there, and then it came, and then it was like kind of quite new. And that time volatility was not supporting Windows 10. So when I did a parsing of image from collected from a volatility from a Windows 10 system, so what I was getting was non-readable character, nothing, like it was not able to parse it correctly. Okay. So that was the kind of difficulty. So in those rare cases, 80% of time you will be getting the profile correctly from the image info, but 20% of time you need to like kind of manually check every profile, or maybe you will end up 5% time not able to kind of parse the image. So that thing you need to be ready, and you need to be knowing the reason why you were not able to kind of parse the image, to maybe to tell your supervisor why this forensics is not possible. Okay. Got it? Fine, Sanjay?
Yeah, Pragyan. And do we run it in command prompt, Pragyan?
Yeah. So
What is the command?
yeah, so as the last time we saw, right, we downloaded the volatility.exe file. Okay. And
Mhm.
then we just give volatility.exe, then -f, and then the image file name, the RAM image, and just the plugin, and that's it, you are done. Okay. So volatility comes for different flavors for Mac, for Linux, and Windows. For Windows, when you download that, you will get .exe version, and you can just, in the command prompt, you can just give volatility.exe and -f this file, and you will like able to parse it with no kind of struggle in kind of parsing this image. Okay, got it?
Got it, Pragyan.
So now what happened, like some of the plugins that we checked last time was PS list. We got the list of processes that are running. And we also saw like, okay, PS list is similar to task manager. So any hidden process you won't be able to see in the PS list. And what we did was we actually executed another plugin called as PS scan that was able to tell us if there are any hidden process. Okay, and reaching before that, there's also one thing which is PS tree plugin, which will actually give you an output in a tree structure. So this means that the sms.exe, the parent of this was system. Okay, and system was having a lot of child process. So as system was having sms.exe, and sms.exe child process were win log on, and then this csrss.exe, and then winlogon we're having different child process like services, and maybe so all the three dots if you see. So whoever have three dots, it means that those processes started from the winlogon. Which has like one dot, that means those are the child of system process. Like system has two child process here, sms.exe and this one, it seems so. Okay, it is still here. Okay, so there is only one single process, and then explore.exe had a child process called reader.sl.exe. Okay, so this is very kind of easy to know. It is very helpful because suppose I am trying to kind of get from here, I know the PID, but it is very difficult to tell what's the parent of that process. So we have to match, like suppose for this one SVC host, I know the PID is 824 and the PPID is 652. So I need to search here which process has 652 PID, and that is services. Then I will tell, okay, services.exe child process is SVC host.exe. But here it becomes very easy to know that I can quickly tell that service.exe child process svc.exe. It's very simple to hear, right? So this is one of the plugin that you can use, that is PS tree. Okay, and now going forward, there is one PX view. So this is what kind of we checked last time to kind of get the hidden process. So what will happen is like the process name will be showing in PS, will not be showing in PS list, but maybe it will showing up in other process like PS scan plugin or thread proc plugin, and it will tell that here it was false. That means SVC host was like kind of not, was a hidden one, but it is showing up in other plugins. That means this process was running as a hidden one. So by this you can know what are the processes that are running hidden in the system. Okay. Now going forward, there are some different plugins too, like con scan and sockets. So it will give you any kind of, it is similar to netstat command. So it will give you what are the established or like listening port number or established communication, all the established network connections that were there when you took the RAM image from that system. Okay. So this is something again quite handy to kind of get the netstat thing. Okay, but this thing will also be kind of readily available if there is any IDS. You are logging the network logs in, like suppose any IDS or firewall or NetFlow logs, you can go get those data from there also. But from the RAM image also, you like suppose you are investigating a client who doesn't have kind of established any firewall log or something in the network side. So at that moment of time, you won't get what all connections were made from that system, but you can get it from here, the world, from the con scan thing. You can get what all established connections were there. Okay. Now going forward, so any questions still now, Saidi, from your end?
No, Praveen, it is pretty much clear, and I think all this PS list, PS scan, PS tree view, this
Yeah.
utility, this is the commands which we have already discussed in the last class, I believe.
Yes. Yeah. Yeah.
Yeah, so it's kind of a revision. So
Okay.
uh, yeah, I'm understanding. So whatever you are saying, and that I'm clear until this point of time.
Okay. So I will just discuss some maybe plugin which we didn't discuss last time. Okay. Somewhere like CMD
Hmm.
line. Okay. So this will tell
Okay.
you what all commands were executed on the using the kind of command prompt. Okay. So you can get all
Hmm.
those commands from here also using CMD line command. Okay. Suppose the attacker opened a command prompt and executed some command like delete all the directory or like kind of uh, send some data out to some other remote server. So if there was any command that are executed, you can
Hmm.
get it from the command line. Okay. So yeah,
Okay.
going forward. Yeah. So these are some of the things we didn't check last time. So there is something called as plugin known as proc dump and mam dump. So what happens? Suppose you get a hidden process running in the
Hmm.
system, and you know the PID value of that. So what you can do is you can just give proc dump and give the process ID of that, like 1643. 1640,
Mhm.
and it will actually dump that memory image from
So is it Windows process ID which
yes,
you are referring here,
yeah,
Pragya?
yes, the
Okay,
window process ID of any of any process. Okay.
fine.
Yeah, so this is the most important stuff. So suppose you know that okay, there is a hidden process and you want to analyze it further, so you take that process out from the memory image and you can like quickly use the proc_dump command. And the benefit of that will be like you either you can start the analysis of your own. Going further, you can either upload that to VirusTotal, get some static analysis from there. Maybe if other users have kind of also checked this earlier, you can see the relation community tab or like details tab of VirusTotal and get any further details what were observed earlier for this process. Okay. So this is something which will be really handy. So once you have the malware, after you dump that out from the memory image, you can follow the same steps what we have learned previously, like static analysis or dynamic analysis of that malware. And there are, and one point, one catch over there is that maybe sometime the process will not be something that you down dump that, but it executed properly. Okay, because what happened, like RAM is a lot of time the pages are in and out, like from RAM it goes to the page file or hard drive, then it comes back again. So maybe some portion of that executable went to the hard drive and it is missing. So what will happen when you execute that, you won't be able to kind of get run it, but you can at least then also you can do a lot of stuff. The stuffs are like a strings command, so you can gather all the strings that were in that malicious process. So from there you can tell, okay, there was a user agent, so the malware is using a user agent, is communicating. So from this you can know that okay, the malware has some capability which is related to communicating with the internet. Okay, and now you also has a user agent. So based on the user agent as the IOC, you can again quickly check if there are any other network, if there are any other device which are connecting to any other IP address using the same user agent. Okay, so this is something that it will be like really helpful for you. Okay, and now going further, okay, now there are some interesting stuff too. So what happened is like most sometime what happened, like when malware is like suppose trying to kind of make any registry based changes, they write to that registry file after some time. Okay, and suppose by anyhow, like suppose the malware got terminated, or you kind of you took the RAM image, but then you turn off the system as malware was not able to write those things in the registry hives. So, okay, so those all data that was to be written, or like what all changes were made to the registry but has not been reflected on disk, you can get those data again from the memory image. So you can just run the hive list command and it will like tell you, okay, what are the registry hives that like kind of active during the time when the malware was actually running the system. And maybe you can get some registry hive like maybe some run like current version run once kind of thing, where you will see that maybe the malware was about to add a path to the malware executable in this directory that maybe have not made it to the disk, but you can still see it from the memory image. So this is something again like kind of quite comes quite handy. Okay, and there is also something known as print key plugin. Okay, so what you can do is like suppose you want to kind of search for any hive list, and like suppose most of the time what happened, malware actually writes the malware executable path in this version, and whenever what happens is like whenever you turn on the system, the malware starts running again. So this registry have actually gives a auto persistence capability to the malware, and you can actually kind of in the memory image itself, without getting the registry hives, you can just write the plugin and give the path of that registry hives that you are interested in, and it will tell you like what are the sub keys in that registry hives, and like what are the data, like you can see the sub keys. You can see that there is a executable that is like kind of that is set to be run at every time when the system will be turned on. Okay, so these are some of the details that you can again get it from the of the registry hive from the memory image itself. Okay, and going further, so these are things. But one thing which is actually missing right now, one more thing which I like to share is actually the Malfine plugin, which is one of the like most important kind of plugin of volatility. So I'll just showcase it to you. Okay, so what happened is like there are some techniques like process injection. Okay, so what happened in process injection, I will just kind of quickly save that. So this is one of the thing which I was like one of the kind of uh, actually the blog that I was actually visiting 3 days before. Okay, and I will just quickly kind of share this link with you. So what happened is like suppose you are actually suppose seeing a process running in the system, like one of the most common process running in the system is actually explorer.exe. Okay, and you think so there might be a case that okay, the analyst see that explorer.exe is running and there is no other process that is running in the system, and they can tell that okay, maybe the system is not compromised. Okay, but what happened is that most of the time malware, when it comes to the disk, what it does is like it injects its malicious code in other processes. Okay, so that what happened, for an example, like suppose I'm running a notepad.exe, I will inject the malicious code inside the notepad.exe. So what will happen is that everyone will think, like most of the normal analysts will think that it is just a notepad.exe, it's not malicious, it's a